Welcome you to Edupedia world. This is the part 3 video of unit testing where I am talking about how to create and work with unit tests in your Matlab program and code. The video has been divided into 9 sections that covers the 3 topics of plugins, constraints and tolerance. The first 5 sections talk about plugins, how to add them, write them, creating custom plugins and using plugins for certain specific tasks. Then I am talking about creating custom constraints and custom Boolean constraints. And in the last section, I am talking about the custom tolerance. As discussed in the previous video, there are multiple ways of executing tests. One of the ways through the runner method. When the tests are being run through a runner method, it provides us with a way to add features to that runner method, or you can say plugins to these tests. Here in this first section, I will demonstrate how to add plugins to a test runner. Now I'm going to demonstrate to you how to add plugins. But before that, let me show you my test class. So here on the screen, you can see my bank account test class that is inherited from the test case class. So basically this test has methods that add account class to path and certain test cases like not enough inputs, test deposit, test withdraw. Test notify insufficient funds. So if insufficient funds is there, then it will notify me. So this is like my basic test class. Now first what I'm going to do is I'm going to create a test suite out of this. So I'm going to create test suite. I'm going to call matlab.unittest.testsuite.from class using the from class method, and I'm going to pass this bank account test class. Bank account test. So my test suite has been created under the variable ts. So here you can see it is size 1x5. So we'll not go into the detail of how it looks like. Now I'm going to run this test, but I'm going to run this with no plugins. So I'm going to create my runner, that is matlab.unittest.test_runner, and I'm going to do with no plugins. So my runner has been created with no plugins. So now I'm going to run the test using this runner. So I'm going to call runner.run and I'm going to pass my test suite to it. So a result has been generated. Result can be seen as name, pass, fail, incomplete, duration. So let me run the same thing but without this semicolon. So as you can see, it directly showed me the result, but it did not show me any progress of what test is going on or has it completed or not. So now what I'm going to do is I'm going to add this plugin that shows me this progress. So for that, I'm going to import matlab.unittest.plugins test run plugins.test run progress plugin, and then I'm going to add this plugin to my runner. Test run progress plugin, but I'm going to add with verbosity 2. So now my runner has been created and I have added this plugin that will show me the test run progress while it is executing the test. Now let me rerun the same command, that is result runner.run, and let me pass my test suite to it. As you can see, now it will show me the status like running bank account test, then done with bank account test, and also the progress for the same. So this is how you can add plugins to your test class, or you can add plugins while using the runner method and the test suite. Apart from adding plugins, you can also write plugins to extend a test runner method. These custom plugins can be used in a way to extend how a test runner evaluates a test content. In this second section, I will be giving a theoretical overview on where exactly these custom plugins comes into play and how you can extend them. The TestRunner plugin methods have 3 levels: test suite level methods, test class level methods, and test level methods. At each of these levels, you can implement methods to extend the creation, setup, run, and teardown of tests or test fixtures. How the test runner run these methods can be summarized as shown in the slide in the figure on the right. Here first there is a test suite level creation method or fixture that is followed by the test class level creation method or fixture, which is again followed by the test level method creation and fixture. The teardown function follows last in first out approach. The teardown for the test level is executed first, followed by the class level, then the test suite level. At each level, there is a report finalized result method that enables the test runner to report finalized test results. A test result is finalized when no remaining test content can modify the results. The test runner is one that determines the invocation of the report finalized result method at each level. The creation methods are the only set of test runner plugin method that have an output argument. So typically, based on the events originating from the test content at the corresponding level, these are the methods that can be extended. Since both test case and fixture instances inherit from the handle class, these listeners and handlers can be used as events to extend the creation methods. The methods that set up, run, and tear down test content, these are the methods that can be used to extend the way the test runner evaluates the test content. The test runner plugin methods at the test level extend the creation, setup, run, and tear down of a single test suite element. A single test element consists of one test method, or if the test is parameterized, test one instant of the test parameterization. Test level, there are four types of method: creation method, setup method, run method, and tear down method. At this test level, the create test method instance method is the only plugin method with an output argument. It returns the test case instances created for each test element. The test framework passes each of these instances into corresponding test methods and into any method with the test method setup or test method teardown attribute. The test framework evaluates methods at the test level within the scope of the run test method. It invokes the plugin methods in this level a single time per test element. One level above this test level method is the test class level plugin. The test runner plugin methods at the test class level extend the creation, setup, run, and tear down of test suite elements that belong to the same test class or the same function-based test. These methods apply to a subset of full test suite that the test runner runs. This also has four types of methods like creation, setup, run, and teardown, and have associated methods to it. At this class level, the create test class instance method is the only plugin method with an output argument. It returns the test case instance created at the class level. For each class, the test framework passes the instance into any methods with the test class setup or test class teardown attribute. A test class setup is parameterized if it contains properties with class setup parameter attribute. In cases where this parameterization has been done, the test framework evaluates the setup test class and teardown test class methods as many times as the class setup parameterization dictates. The run method at this level, that is the run test method, extends the running of a single test suite element and incorporates the functionality described for the test level plugin methods. The test framework evaluates method at the test class level within the scope of the run test class method. If the test class setup completes successfully, it invokes the run test method one time for each element in the test array. Each test class setup parameterization invokes the creation, setup, and teardown methods at a single time. The test runner plugin methods at the test suite level extend the creation, setup, run, and teardown of shared test fixtures. These methods fall within the scope of run test suite. At this level, the create shared test fixture method is the only plugin method with an output argument. It returns the fixture instances for each shared fixture required by a test case. These fixture instances are available to the test through the get shared test fixture method of the test case. The run method at this level, that is run test class, extends the running of the tests that belong to the same test class or the same function-based test, and incorporates the functionality described for the test class level plugin methods. In this third section, I will be giving a short demonstration using an example on how to create a custom plugin.
Here the plugin will count the number of passing and failing assertion when running a specified test suite. The plugin prints a brief summary at the end of the testing.
Custom plugin, we have to inherit TestRunner plugin and create a class on it. So here I have created my own custom plugin, that is the assertion counting plugin. So basically this will count the number of passing assertions and number of failing assertions. So to keep track of that, in the properties block I have created these two variables, that is number of passing assertion and number of failing assertion. Now what I'm going to do is I'm going to extend the run test suite method. So run test suite method is something that takes in the plugin and also the plugin data. So basically this method is evaluated by the test framework only one time. So this function displays the information about total number of tests. Then it initializes the assertion count for each of them, that is passing and failing assertion. Then it is invokes the superclass method, that is this one, TestRunner plugin method. And after the framework completes the evaluation of the superclass method, the run test suite method displays the assertion count summary. Now what I'm going to do is I have also added listeners to the assertion passed as assertion failed event to count the assertions. So to add these listeners, we extend the methods that test the framework that uses to create the test content. So for that we have this create shared fixtures. So we have three methods actually. One is a create shared test fixture, one is a create test class instance, and another is a create test method instance. So in all three of them, I have added the listeners, that is for fixture, that is add listener, fixture.add listener assertion passed, and then I'm incrementing the passing assertion count. Then again, similarly, I'm doing that same with the assertion failed, and then I'm incrementing the failing assertion count. Similarly, while it is passing in the test class, then what I'm doing is I'm adding listener there as well. So assertion pass listener is there. It will increment the assertion count, assertion failed. And similarly in the method case, if assertion is failing, we will count that as well. So next we need to do is we need to extend this run test method. So basically what this does is this only shows the display like which test method is running, and it then calls to the superclass method and passes our plugin to it. Then apart from that, we have three helper functions. So these helper functions are basically called by all these above functions. So one of the helper function is incrementing passing assertion count, that does nothing but increments the assertion count. Similarly, there is another one that is incrementing failing assertion count, that increments the, whenever the assertion failure happens, it increments that. And we have a assertion summary that basically prints the summary for all the passed and failed assertions. So this is my custom plugin. Now let me give you an example of my test class. How do I use it in my test class? So consider this. This is a very simple example test class that is derived from the test class. It has three functions, test1, test2 and test3. Now let me show you how to add this custom plugin. So first what I'm going to do is I'm going to create a test suite out of this example test. So I'm going to write ts is equal to matlab dot unit test dot test suite dot from class method, and I'm going to use this example test class. So my test suite has been created. Now what I'm going to do is I'm going to create my runner, but this runner will have no plugins. So I'm going to use Matlab unit test dot test runner dot with no plugins. So my runner has been created. So first let me show you how the execution looks like without this custom plugin. So I'm going to run this test runner.run and test suite. So as you can see, it immediately gives us with no failure, like how many assertion fail, how many pass, just this test result block. So now what I'm going to do is I'm going to pass this test plugin to this runner method. So what I'm going to do is in the runner, I'm going to add my plugin assertion counting plugin. So I've added this plugin to mine. Now I'm going to do is I'm going to run my runner again, runner.run, and pass my test suite. So as you can see, Yes. So as you can see, after execution, it shows me that there will be total 3 test cases that will be run. So listener with properties, assertion passed. So whenever the assertion is passed, I get this information, and with all these properties, and whenever the assertion fail, I get this information. So first it is running the test, that is example test 1. Then it has passed, it has failed. Then again it is running test 2, it has passed. Then again it is running test 3, which has passed and which has failed. So this is how total assertion failed. There are 2, so 1 pass, 1 failed, and like this I get a very detailed summary. So this is how you can add your custom plugin to your test case.
Plugins can also be used to save diagnostic details. I will give a demo for this in this 4th section. Here my plugin will listen for test failures and will save the diagnostic information so that it can be accessed after the framework completes the tests. So before moving on to the code, let me tell you what I have done. I have created a plugin that inherits from the TestRunner plugin class. In that, I have first defined a failed test data property on the plugin that stores information from the failed test. Second, I have done is that I have overridden the default create test method instance method of the TestRunner plugin to listen for assertion, fatal assertion, and verification failures and to record relevant information. Third, I have overridden the default run test suite method of the TestRunner plugin to initialize the failed test data property value. Then at last, I have defined a helper function, that is record data, that will save the information about the test failure in a tabular format.
Custom plugins can also be used to record diagnostic data. An example for the same is this diagnostic recorder custom plugin that I have created. So basically, this is a plugin that has been inherited from the TestRunner plugin. It has a property of failed test data. So this is the property where I will store all my failure diagnostic data. In this run test suite method, I have initialized this failed test data. So I have done this to clear the test data every time we call the runner. So this will prevent any new data to be appended to the older data. So every time this failed test data will be reinitialized. Then in the create test method instant, I'm overriding this and I'm adding my listeners to it. So I'm adding the assert failure listener to it, I'm adding fatal assertion failure listener to it, and I'm adding verification failure listener to it. So whenever this failure will occur, this record data helper function will be called and the assertion and the data will be stored in the failed test data. Now for the helper function, I have put this access to private. So, and I've created this record data helper function. So what this will do is this will take all the information at that point of time whenever it is called by the listener, and it will store in a structure tabular format, and then it will push that data to the failed test data. So outside the class, we can access this failed test data for each of the test cases. Now for the same, I have developed this test class that is diagnostic test that has 1, 2, 3 and 4 test cases. So the test 1 does an assertion for greater than 5 and 10. Then in test 2 we have verify empty, verify class. In test 3 we have assert equal, and in the test 4 we have a fatal assertion. So what will happen is when I run this test case, the Matlab will throw an error saying that fatal assertion has happened and it will stop. And after that we are going to take out the failed test data from this diagnostic recorder plugin and we will see what it shows. So for that, let me create a test suite first. So I'm going to create a test suite matlab.unittest.testsuite from class, and I'm going to pass this diagnostic test class to it. So my test suite has been created. Now I'm going to create my runner but with no plugin. So first I'm going to import matlab.unittest.testRunner. Now I'm going to create my runner object and I'm going to put TestRunner with no plugins. So basically this means that my runner currently has no plugins. Now I'm going to add a plugin like that is diagnostic recorder plugin to this. So plugin, add plugin, and I'm going to pass diagnostic recorder plugin. Now my runner is ready. Now what I'm going to do is, okay, this is something that I did incorrectly. So to get the failed test data out, we need to first instantiate this diagnostic recorder plugin. So what I'm going to do, I'm going to instantiate this with and put it into variable P. So diagnostic recorder plugin, and I'm going to add this runner add plugin P. Now I'm going to run my test suite runner dot run and ts. As you can see, it stopped at fatal assertion. Now from the object P, I'm going to get this failed test data. So as you can see, for all the test cases 1, 2, 3 and 4, it has given me type, that is assertion, verification, verification, assertion and fatal assertion. And then it has shown me stack, timestamp and framework diagnostic. So basically we can get the stack information, framework information, test diagnostic information, everything from this failed test data. So this is how we can extend the plugin or write custom plugins to record diagnostic data.
In this fifth section, I will demonstrate how to create a plugin that uses a custom format to write finalized test results to an output stream. Before moving to demo, I will briefly explain what has been included in the custom plugin. In the plugin class, I have defined a stream property that stores the instance of output stream. By default, the plugin writes to the standard output. The second thing that has been done is that I have overridden the default run test suite method of the TestRunner plugin to output the text that indicates the TestRunner is running a new test session. This information is useful if you are writing to a single log file, as it allows to differentiate between the test runs. The third thing is that I have overridden the default report finalized result method of TestRunner plugin to write the finalized test results to the output stream. Here you can modify the print method to output the test results in a format that works for your requirement.
Plugins can be modified to be used to manipulate the way how we write out test results to an output stream. This stream could be the standard output or could be any other file. So to demonstrate the same, I have created this custom plugin, that is example custom plugin, that will write test results and data to a particular stream that will be provided by either the user, or it will write to the standard output. So here I have the property of stream. So in the constructor of the plugin, it will look for the stream input argument. If user does not provide any input argument, then it will write the test results to the standard output. If user provides input argument like a file name or location, then it will go to that file and it will write all the test results and data to it. Now what I'm going to do is I'm going to extend this run test suite method. So in this, I'm going to add only one line, that is new test session started, and I'm going to print this into the stream. This I have done to differentiate between the each test run. Then the second thing I'm going to do is I'm going to override this report finalized result, and according to this result, I'm going to set the status like passed, failed and skip. And in the output stream, I'm going to write like this test at this point of time has passed and it took this much of time. And then I'm going to again call the super class of the report finalized results. So these are the things that I have added in this report finalized result in this run test suite method. Now to test this plugin, I have created this test class, that is example output format test, that has 4 test cases that will test out individual cases. Now let's see how this works. So first I'm going to clear my command window. I'm going to import. First I'm going to create my test suite. So test suite Matlab dot unit test dot test suite from class, and I'm going to put my class, that is the example output format test. So now my test suite is ready. Now what I'm going to do is I'm going to create my runner. So for that I'm going to import Matlab dot unit test dot test runner, and I'm going to create my runner object. So I'm going to create this object with no plugins. So my runner object has been created with no plugins. Now what I'm going to do is I'm going to first create a file name, like file name is equal to, I will say test underscore results dot txt, and I'm going to instantiate my plugin. So my plugin here is example custom plugin, and I'm going to pass this matlab.unittest.plugins.to file, and I'm going to pass this file name. So basically what I have done here is I have told my plugin to write all your test results into this file. So my plugin has been created. Now I'm going to add this plugin to my runner. So I'm going to use add plugin method and add this plugin to my runner. Now my runner is ready. Now I'm going to run my test suite using this runner. So runner.run, and I'm going to pass my test suite. Now all my test results and data has to be stored in this test underscore results.txt. So now let me show you how this file looks like. So as you can see, this file looks like something like this. So new test session that has been started at this. So I will open this as well and verify it. So as you can see, it started the new test session, but due to some reason it was not able to run the test. So if it is able to run the test, all that would be stored. Assumption failure in test cases do not produce failures, but it has the possibility of creating dead test code. Avoiding this requires monitoring of the filtered test. Whenever an assumption failure happens, it marks the test as incomplete and it skips the test. Here in this section, I am going to show how to use this information and select the incomplete test from the original test suite. Let me demonstrate to you how we can filter incomplete tests from the passed and failed tests. So for that, consider this test case class, that is filter test, that has three test cases: test A, test B, and test C. One has a verification true, one has an assumption equal, and one has a verification false. So now let me run this test. So first I'm going to clear this. I'm going to create my test suite, matlab.unittest.testSuite.from class, and I'm going to pass this filter test class to it. So my test suite is created with three test cases to run. Now I'm going to just simply run this test suite. Let's see what happens. So basically, if you observe, there is one passed test case, there is one failed test case, and there is one incomplete test case. So MATLAB allows, as this result is a tabular format, so MATLAB allows you to get the information of the incomplete test case or passed test case or failed test case. So how you can get that? So to get the information of incomplete test case, we will just call the result, and in the result dot incomplete, I'm going to index it using result dot incomplete. So as you can see, test B was the one that was incomplete because it was assumption was failed. And using this information, we can actually filter the incomplete test cases from our original test suite. So I am going to create a new test suite, that is the test suite filter. And I'm going to index the test suite and filter out these incomplete test cases. So this is how I've done the indexing. And now my test suite filter only has this incomplete test case. Now I can rerun this test case if I want. But again, I know that this will still be incomplete. So this is how we can isolate the incomplete test cases and execute them. Where we want to filter our test cases dynamically. So that can also be done, and that is called filtration by assertion. So basically here I have extended this filter test class and I added two setup methods, setup method 1 and setup method 2. So in the setup method 1, it does an assume equal for 1 and 0, as this assumption will fail. So rest of the test code will not be exercised. Whereas in the setup method 2, it does an assertion equal. So as this assertion equal has passed, so it will filter all the test cases, that is test A, B and C, based on this assertion. This sounds confusing, but let me show you how this works. Again, I'm going to clear this. I'm going to create my test suite, Matlab unit test suite from class, and I'm going to pass my filter test class to it. So my test suite is now created. Now what I'm going to do, I'm going to run this test suite.run. So as you can see, it has let me take you to the top. So after running the filtered test, test A was filtered. Now it is running method 2. Now in this method 2, test B was filtered, and again test C was filtered. So basically test setup method 2 has been called 3 times. So in this final summary, you can see that all these 3 test cases, that is test A, test B and test C, are filtered by assumption. So basically, because this assumption was passed in the setup method 2, hence these 2 test cases have been filtered by it. So this is how you can dynamically filter test cases. This is actually, to be honest, a very simple example of how this is used. In a more complex testing framework where we are testing more number of cases per second and in a real-time testing simulation environment, this actually comes out to be very helpful to isolate or to actually eradicate certain number of tests, basically skip certain number of test cases and directly go to the test cases that you want to execute. So I hope this example, this very small example, could actually make you clear how you can actually filter the test cases. In this 7th section, I am going to demonstrate how to create a custom constraint and use it. Here I will create a constraint that determines if a given value is the same size as an expected value. I will first explain the segments in the code and then go on to give a brief demo for the same. The custom constraint is created by inheriting the constraint class from the unit test framework. The value with the expected size is stored in the variable of the same name that is defined in the properties block. This property has been set to be immutable because it is recommended that the constraint class implementation are immutable. Classes that are derived from the constraint must implement the satisfied by method. The method must contain the comparison logic and return a Boolean value. Here I have added the satisfied by function where I am checking whether the actual size is equal to the value with the expected size. If it is false, the function returns false, and if it is true, then it will return the true. Another function that needs to be implemented for the classes that derive from the constraint class is the getDiagnosticFor method. This method must evaluate the actual value against the constraint and provide a diagnostic object. In this example, getDiagnosticFor returns a string diagnostics. So here if the constraint has satisfied, then the string that will be passed will be like pass string, and if it has not satisfied the constraint, then it will pass the string as failed string. This is what the code looks like for the custom constraint that we discussed in the previous slide. So this is my custom constraint that has same size as, that is derived from the constraint class. It has this value with expected size as an immutable property. So it has this constructor that takes in the value with expected size. Then it has to override satisfied by function and getDiagnosticFor function. So satisfied by function tests for equality between the sizes and returns true or false based on that. GetDiagnosticFor function does the same but returns a string output like has same size as passed or something like has same size as failed based on the passing and failure of the test class. Now let us see how to test this out. So for this I'm going to do an interactive testing. So to do interactive testing, I'm going to import Matlab .unittest.testCase into my command prompt. Now I'm going to create a temporary variable test case that will be, I'm going to refer to the test case of that Matlab class, and I'm going to say for interactive use. So my test case object has been created that is ready for an interactive use. Now let me pass it on a case that will actually pass.
So I'm going to do test case. I'm going to verify that the size of zeros has the same size as a repeat matrix of 1, 5. So basically I'm verifying that the size of zeros of 5 cross 5 is same as the size of 1 cross 5. So let's see how it says. So interactive verification has passed. Similarly, let me take a fail case that I definitely know is going to fail. So I'm going to say test case dot verify that again zeros of 5 has same size as ones of 1, 5. So this will show that the verification has failed. So here it shows that the actual size is 5 cross 5 and the expected size is 1 cross 5. So this is how interactive testing works, and this is how a custom constraint is written and used.
In this 8th section, I will show how to create a custom Boolean constraint. Here I have created a class has same size as bool that is inherited from the Boolean constraint class. The constructor accepts a value to compare with the actual size. This value is stored within the value with expected size property. As this is derived from the Boolean constraint class, which is derived from the constraint class, hence this property is supposed to be immutable. The Boolean constraint class is a subclass of the constraint class. I am deriving from the Boolean constraint class, so now I need to implement the satisfied by and get diagnostic form methods, as these have to be implemented from the any class that is derived from the constraint class. Here I have done the same. In the get diagnostic for method, I have returned the appropriate string when the test case is passed and failed, and in the satisfied by method, I have passed the Boolean value of pass and fail. I have also added a get negative diagnostic for method in the method block with protected access. This is because this class has been derived from the Boolean constraint class and it needs to implement the get negative diagnostic for method. This method must provide a diagnostic object that is expressed in the negative sense of the constraint. This means that if the constraint is satisfied, then it will pass the string something like that says negate has same size as failed as actual and expected values should not have been the same. This you can see here in the code. So this message is like opposite to that of get diagnostic for method.
Now I'm going to demonstrate about Boolean constants. So these are similar to the constant that we saw in the previous section, but in the case here it is specifically inherit from the Boolean constant class. Boolean constant is also inherit from the constraint class. So here I have my custom constant that is has same size as Boolean. So again it has properties that has value with expected size. It is set to immutable as it belongs to the constraint class. It has its own constructor where it takes in the value and stores it as a value with expected size. As it is finally derived from the constraint class, so it has to implement satisfied by method and get diagnostic for method. So satisfied by method will return true or false if the size matches with the constraint. If the size does not match, it will return false. Similarly, get diagnostic for method returns strings. If the size is satisfied, then it returns has same size as pass, and if the size does not satisfy, it returns has same size as fail. So one more thing that has been implemented in the Boolean constant is a get negative diagnostic for. So basically this constant can be used both for non-negate purposes and negate purposes. So I will show you how it is done. So in the get negative diagnostic for, we just switch the output. So if the size matches, we will say negate size has failed because actual value and expected value were the same, but they should not have been. Similarly, if it is false, then we will write out negate has same size as passed. Now let us see how this will work, how this Boolean constant will work. I'm going to clear this first. Now I'm going to import test case first. Import matlab.unittest.test case. I'm going to create my own test case object. as test case dot for interactive views. So now I can interact with my test case object. Now first I will show you a passing condition. So test case dot verify that zeros of size 5 has the same size as repeat matrix 1 comma 5. So here it will obviously verification will pass because it is the same size. Now let me show you how to use the negate of this Boolean constant. So this is a failing case. So test case dot verify that I will again take zeros of 5 and I will negate has same size as bool and repeat matrix 1 comma 5. So it is said that interactive verification had failed. So even though the size is same, as we have used the negate, hence we are saying that the actual value and expected value were the same, but they should not have been. So this is how a Boolean constant is used and is implemented.
In this 9th section, I will demonstrate with an example the use of custom tolerance. Here in this example, I will show how to create a custom tolerance to determine if two DNA sequences having a Hamming distance within a specified tolerance. For two DNA sequences of the same length, the Hamming distance is the number of positions in which the nucleotides of one sequence differ from the another. Let us see with a demonstration.
In this demonstration, I will show you how to work with custom tolerance. So first, let me show you the DNA class. So using this DNA class, I will be creating my two samples. So this class is nothing but a constructor that checks for the sequence having valid characters of A, C, T and G. If all are not valid characters, it will return an error that the sequence contained a letter that is not found in the DNA. Otherwise, it will pass on the correct sequence back to our samples. Now for the same, I have created a Hamming distance tolerance. So basically, what I will do is I will check whether the sample A is equal to sample B or not. If it is not equal, then I'm again going to check whether sample A is within one Hamming distance of sample B or not. If again it is not equal, then I'm going to check whether sample A is equal to 2 Hamming distance of sample B or not, and so on. So for that, I have created this tolerance class Hamming distance that has a property of value that takes in the value as a constructor and stores in its property. So as it is a tolerance class, it needs to have this support function. So this support function takes in the value and check whether it is actually a value or not. Then as the tolerance class is taken from the constraint class, so it needs to have a satisfy by method implemented. So if both sequences match, then it will pass a true. If it does not match, it will pass as false. If both sequences match within the Hamming distance under the given tolerance, then it will also return as true. Another function that we need to implement is the getDiagnosticFor function. It is similar to the satisfied by, but it returns in the textual form. If the sequence match, then the sequence have a Hamming distance of this and allowable distance is this. So basically it will send out the string diagnostic as it is required. Now I have two helper functions, that is the is same size and Hamming distance function. So this is same size is the one that checks whether both are of exact same size or not, and it will return true or false. And Hamming distance is the one that checks whether they are not of the same size, and then it comes into the tolerance checking like here. And if it is within the tolerance, then okay, it has passed. Now let us see how this works. So first I'm going to clear this. First I'm going to import the test case, that is unit test dot test case, and I'm going to create my test case object for interactive views. Test case dot for interactive views. Now I'm going to import is equal to from the constraint as well. So I'm going to import Matlab dot unit test dot constraints dot is equal to. So I think there is a spelling mistake. Constraints is equal to. So yes, there was a spelling mistake in the constraint. So now I've imported the is equal to function as well. Now I'm going to create my sample DNA. So I created sample A. I'm going to call DNA class, and I'm going to find some character sequence like A, C, C, D, G, A, G, T, A, something like this. And I'm going to create my sample B. Again, I will call the DNA class, and I will pass something like A, C, C, A, C, A, G, T, A. So now my two samples are ready. Now using the interactive test case, I'm going to verify whether they are equal or not. So for that, I'm going to use test case, verify that sample A is equal to sample B. Now let us see what is the answer. So it is saying no, these two are not equal, as obviously these are not equal. So now what I'm going to do is I'm going to again use test case dot verify that sample A, then I'm going to say is equal to sample B, but I'm going to write the condition within Hamming distance of 1. So now I'm going to check whether sample A is within one Hamming distance of sample B or not. Again, this has failed. Now I'm going to do is I'm going to check whether it is under the Hamming distance of 2 or not. Now as you can see, the verification has passed. So basically this is how a custom tolerance work. This is just a simple example for DNA. This can be applied into any form of engineering application like electrical, information technology and data analytics and whatnot. So this was just a small demonstration of how to use a custom tolerance. This concludes this 3-part unit testing topic as well as this web series on basic of Matlab. Thank you all for watching this web series. For any comments and queries, feel free to comment on the videos, and you can even contact me through email or through my blog. I hope these videos have helped you viewers understand Matlab a little better. So please subscribe, and thanks for watching.